So first we're going to be talking about inverses. So we're going back a couple units talking about inverses. There are 3 different ways for us to find them. So if you're given a set of points, how do we find the inverse? You got to switch your x and your y. So your x's from your original function are now the y's of your inverse, and the y's from your original are now the x's of your inverse. So you just switch your points around. If we're graphing, we're going to find our inverse by reflecting over the line y equals x. We refer to that line y equals x as our inverse line, or a line of inverse. And then for the equation, this will help you out a lot on your algebra sets that are due Friday. So if we're trying to find the inverse of an equation, first thing we have to do is switch our x and our y. So after we've switched our x and our y, what do? Logan? Solve for x. Or y. Let's go for y. Because whenever we graph things, what do we always have to have it in? Y equals form. So we want to solve for y, not x. So let's take a look at our graph here. This is a graph we did last unit, y equals 2 to the x. So what I want you to do is go in your calculator, type that under your y equals, and let's get our table of values. We'll go from -2 to +3 in our x's. Thank you. Oh, I didn't need 16, but thank you. That is for a quadratic, which is your parabola. And what's the other thing we always have to put with our graph? The asymptote. So now we're going to graph our inverse. So to graph our inverse, we just take our original table and we just switch our points around. So our x would now be 0.25, 0.5, 1, 2, 4, and 8. Whereas our y's is -2, -1, 0, 1, 2, and 3. Is anybody willing to venture a guess where our asymptote is now? Nope.
No, it's going to be on the x-axis.
Or the y-axis. But yes, it does switch and becomes vertical. X equals 0. So as I was saying up above, the one we don't do as often is I could have reflected it in the line y equals x, which is this line right here. Or the easier way, which is the one we did, we just took our points and flipped it. So that's our couple of ways we can do to reflect the graph. So now they want us to write the equation for our inverse. So to write the equation for our inverse, I'm going to take the original one, y equals 2 to the x. And then as we set up above, we switch our x and our y. So x equals 2 to the y. And now we have to be able to solve for y. So how would I get that y out of the exponent spot? But if I just multiply both sides by y, then I have xy equals y times 2 to the y. Yeah. Well, if we use a root, then I still have that root over here, and it doesn't really get y by itself. It's a root, not just y. And this was the dilemma that people had. They didn't know how to get y out of that exponent spot. So what happened is many, many years ago, somebody's like, all right, we got to create something new in order to get the y out of the exponent spot, and that's when they created the log. So to get y out of your exponent spot, it became log. They write the base here and the answer over here. Y represents your exponent. So what that's saying is the exponent on the base of 2 is going to give you an x. Y is the exponent on the base of 2 that gives you an x. So log is just a really fancy word that means exponent. So that's like the biggest thing I need you to take away from today. Log is exponent. So whenever I ask you, what is a log? Exponent. Don't tell me a piece of wood. Exponent. Nice job. So if we're plugging in our letters here, this would be y equals log. And the 2 gets written as a little 2 down towards the bottom. It's like in the opposite position as an exponent. Exponent's up top. This 2 is what we call subscript. It's down lower. And then the x would go there. So y equals log base 2 of x. I'm sorry. You use logs a lot in chemistry. You're going to have fun with that. So after I wrote these notes, I realized I should have put them in a different order. So we're going to jump around a little bit. So what I want you to do is go to the back of this page down to the bottom. No, we're going to go back to it. I want to practice first converting between log form and exponential form. So for our log form, it's log, the base goes there, answer here, and it equals exponent because your log is an exponent, so log always equals exponent. Log is exponent. So if we look at problem number 1, what is our base in there? 2, because it has the exponent attached to it. So this is going to be log with a little 2 there because 2 is our base. Our answer is what? Our answer is 5, and it equals your exponent, so it equals x. So it's base, answer, and then exponent. So what happened is, last year as I was going through this, somebody taught me a little trick that they found helpful to help them remember. When you're putting it in log form, you want to write your capital L. So what they did is they would come down, hit the 2, go over, hit the 5, and then come back for the exponent, and it looks kind of like a big bubble L. So if that helps you, go for it. Let's look at our second example. What is our base there? The 4. It's written in a different way. The 4 is on the opposite side of the equal sign than it was for the first one, but it's still the 4. Our answer is 6, and it equals our exponent, so it equals z. So it goes here. You might like writing the L. That tells you what order to use the numbers. So the 3 came first. So it's log little 3. Then it hits the A equals exponent. Because A was right here. So my capital L, when I drew it, hit the 3, then it hit the A, then it hit the 5. So that's the order I use them in. So going back the other way, when you're putting it into exponential form, so it's given to you in log form, you're trying to leave log form. You want to do what I call write the E. E is for exponential. So it's kind of like a little lowercase cursive e, and I remember how much you guys love cursive. But you start here with your base, you hit your exponent, and then you get your answer. So this is 5 to the x equals 125. That's putting it in exponential form. Now 5, it does still work with that, only 5 is written backwards, so your e would have to be backwards. But here's your base, exponent, and then you get your answer. So 27 to the 2/3 equals x. Anybody willing to guess for 6 what it would be?
Yeah.
What do you got, Dan?
3.
Perfection. 3 to the x equals a. And then for number 7, is there base written? No. What is it? No. If there is no base written, it's a base of 10. Reason being, we have a 10 or base 10 number system. It consists of 10 numbers that it just repeats over and over again. That's a simple explanation. So if there is no base written, it's always a 10. So this would be 10 to the 2 equals w. Let's go back to the graph on the first page. We're going to do our graph first. Yeah, we're going to go back to the front. We're going to do the graph of our log function. So when you go to graph this, you can't type into your calculator log base 3 of x in order to graph it. It doesn't happen. So first thing we need to do is rewrite it as an exponential function. So this would be base 3 exponent of y equals an x. So can I still type that into my calculator?
Thank you.
Because, yeah. So can we type that in the calculator yet? No. So it's a little tricky, but what we have to do is we have to take the inverse, which is y equals 3 to the x. We type that into the calculator and just switch your x and y's to get your table of values. Because we can't type log into the calculator. Because, I mean, you still have to know how to do some things. So go ahead, type in your calculator under y equals, type in your 3 to the x power. So it's going to be the x values of your table. We're going to use them as the y values of this because we actually want to graph the inverse of it. So we're going to go from -2 to 3. So what's our decimal that goes with -2? 0.1 repeating with -1. With 0. 1, 2, and 3. So then we'll go ahead, plot our points. With your decimals, you're just kind of estimating where they are. We get our little sideways Fachat graph going on here. So along with your sideways Fachat graph, we should have our asymptote there. All right, so let's look at our domain. What is our domain going to be for this? Does it ever cross and equal 0? No, so it's never negative. So x is greater than 0. It's only going to be positives. It'll never be 0 or anything less than that. Our range, however, would be y is an element of the reals. It's going to be every single y value, or it could possibly be every single y value. Our x-intercept would be at 1. And then our vertical asymptote, hopefully you've already labeled it, but that would be the line x equals 0. All right, let's go to the next step. So you got to understand that when you're writing in log form, you can write it also like that in exponential form. You have two ways it can be written, log and exponential. It says y is the exponent that you bring b to in order to get x. That's one way of reading through it. But as I was saying before, main thing, logarithm means exponent. Log is exponent. So when you're evaluating logs, like we have to here, we first need to have an x in there. There's no x there. So I'm going to set that equal to an x. So I have log base 2 of 8 equals x. So now what I'm going to do is I'm going to take it out of log form, like we all just practiced. So it would be 2 to the x equals 8. And then this brings us to what we were doing last unit in our warm-up today. 8 is 2 to what power? 2 to the third. So therefore, x equals 3. Let's try the next one. So again, first thing I can do is set it equal to x. I need to have it equal to something. I'm going to take it out of log form, put it in exponential form. So that'd be 4 to the x equals 16. And then we can rewrite 16 how? 4 squared. So therefore, what does x equal? 2. Third one, what do we set it equal to? Set it equal to x. So writing it in exponential form, what would it look like? Logan? 3 to the x equals 1 over 3. So then how do I rewrite 1/3? 3 to the negative 1. So x equals negative 1. So our next one, I'm missing two things. I'm missing my base, and it's got to be equal to something. So I'm going to write in my base of 10. And it's going to be equal to x, just like the other ones. So our exponential form would be 10 to the x equals 100. Let's see if we can do this in our heads. 100 is 10 what? 10 squared, so therefore x equals 2. Now for the next one, we have ln instead of the word log, which we're going to talk about ln more in a couple of days. Ln means that the base is an e, which remember we talked about e last unit. It's that natural number that exists in the world. Oh, I didn't mean to write 0. I was thinking of something else in my head. Sorry. Equal to x. So it's the same way of taking it out of ln form, putting it in exponential. But then there's really nothing else we can do just yet because I haven't taught you guys how to do that stuff yet. You can't take e and do change of base with it to make it a 5. This one, last one, set it equal to x. And we get 2 to the x equals 5 when we put it in our exponential form. And again, can we make 2 to a power to get us 5? No. So these two right here are things we're going to be doing in a couple days. It's like a little preview. Soon to come.
Another one of those next time in math class.
Coming to a math class near you. How to finish solving those. I know, because you needed logs to finish it. Hey, what are we doing? Yeah. So we'll be able to go back and finish that question.
Go back.
All right, let's take a look at our last page. This last page is going to be pretty easy because it's just like what we were doing with our evaluation. So to solve the log problems, you need to put it in exponential form. So then once you put it in exponential form, you can solve it like we did pretty much for our entire last unit. So for 1, it's going to be 5 to the x equals 125, or 1 over 125. 5 to what power is 125? 5 to the third. And since it's a fraction, that means the 3 is what? Negative. So 5 to the x equals 5 to the negative 3. So x equals negative 3. Second one, done the same way. They just put it in different order. So it's going to be 4 to the negative third equals x. So because the negative, that means the 4 would become a what? Fraction. But it's a 1/3. Can I take the third root of 4? No. So let's type this one in and get our decimal. Type it in your calculator. We'll get a decimal for this one. It's one of the few times you would actually have a decimal because you can't actually take the third root of 4. 1.587401052. Type in 4 to the negative 1/3 power. That sounds better. 0.629 what? Oh, slow down. 0.6299605. There we go. You should always write the whole decimal unless they tell you to round.
Chemistry, we usually do 6 days.
Oh, see, it's not chemistry. Yeah. All right. Number 3, again, let's put it in exponential form. So it's going to be 5 to the second equals x minus 3. So 5 squared is what? 25. Then what do we do with our 3? Add it. So x equals 28. Then our last one, what's our base? 10. So we get 10 to the negative 3 equals x. Because if there's no number written, your base is a 10. Always. So that makes it 1 over 10 to the positive 3. So that makes it a 1 with 3 zeros. So 1 over 1,000.